Okay, so let's get started. I can see people are joining. Again, good morning, good afternoon, everyone. I'm super excited about today's session. We have a special guest today, who's a co-founder and R&D lead at Innerspace. Matt, do you want to introduce yourself?
Hey everybody, my name is Matt. As noted, I'm the VP of R&D and co-founder at Innerspace. So we've been through this journey for quite a while and happy to talk about StreamNative.
Awesome. Thanks, Matt, for being here today. Yeah, and I'm Kundan Vyas. I'm a part of the product team here at StreamNative. Yeah. So let's get started. So quickly, just to give an idea about the agenda, I think we'll be covering a lot more content than what's listed here. But we'll split this into two separate halves. Like the first section, I'm going to cover a quick introduction to StreamNative for the folks who are not familiar with StreamNative, and get into some of the use cases for stream processing, because today's session is a lot more focused on the data stream processing use cases and aspects. So I'll cover that. I'll introduce you all to the built-in capability within StreamNative for doing the data stream processing, and I'll give a quick demo. And then I'm going to hand it over to Matt, who's going to cover everything about the Innerspace, some of the core use cases they focus on, what is their business domain, and then, he's going to talk a little bit about their adoption of Pulsar and, particularly StreamNative functions and the journey so far, right? And the deployment process. So yeah, that's going to be definitely a very exciting session. I'm looking forward to that one. And then we'll have some time for Q&A as well. So let's get started. And it's 9:04. So again, just for the benefit of folks who are not familiar to StreamNative, basically just a quick journey with milestones here. So StreamNative is a company which is created by the founders of Apache Pulsar. So back in 2012, basically Apache Pulsar was sort of created as a technology at Yahoo, and then it was open sourced in 2016. And in 2018, it went through various stages of the life cycle of any Apache Software Foundation lifecycle project, and became one of the top level projects for a certain duration of time. And then so that's definitely been a great journey there, taking the product from creating it and then open sourcing it in 2018. And then in 2019, the company StreamNative was formed. And then we started providing managed services for Apache Pulsar, and basically helping customers adopt Pulsar and operationalizing, all the difficult things which typically are involved in setting up and fully managing a Pulsar deployment. So 4 years were great. I think a lot of growth in the community side for Pulsar, and also for StreamNative. A lot of capabilities were launched. I won't go into too much of that. But in 2024, also, again, we launched a lot of capabilities. But there's one thing which I really wanted to highlight today, which is the support for Kafka. So we launched Kafka compatibility in Q2 this year. And what that means is we also fully support the ability to kind of run Kafka. You can sort of connect your different applications to Kafka clients to get data in and out of StreamNative Cloud within Kafka topics, right? So I'll chat a little more about that later. But if there's one thing I want you to take away from this slide, is that StreamNative is, of course, a Pulsar company, but we are also a Kafka company now. We are a vendor for Kafka. So just some background there. So let me introduce you to our one StreamNative platform. Essentially, StreamNative at the center, we basically, as I mentioned, we support both Kafka and Pulsar. We offer fully managed services for that in our cloud and in our private cloud. Basically, we also have 50+ connectors, which help you get data in and out of StreamNative, right? So source connectors and sync connectors. And for some reason, if you don't have a connector which you're looking at, and for some reason you have the reasons to write custom code to send data or receive data from StreamNative Cloud, you can use our client libraries. We have a long list of language runtimes we support in the corresponding SDKs. We also support a capability, an out-of-the-box feature within StreamNative platform to basically write data to your favorite destination, whether it's S3, Google Cloud, or Azure Blob. storage in a lakehouse storage open format of your choice. Like it can be Delta Lake or Iceberg or Hoodie. So you can choose to just as turn on that capability and specify the format in which you want to push that data. And these formats are becoming more and more popular, getting adopted by different companies and in the industry. You must have heard a lot going on in this area. So I think we are proactively supporting this capability as an out-of-the-box feature. We also support integration with the popular heavy-duty data processing and stream processing like technologies like Flink and Apache Spark. We have connectors for those. We have a Spark connector for Pulsar and similarly for Flink. So that can be very much used. And then we have a built-in capability within StreamNative Cloud. This is a native capability which runs on top of Apache Pulsar, but now available as a fully managed service within StreamNative Cloud. It lets you do some lightweight data processing. Today I'll be talking a lot more about this, so I'll cover that very quickly. We also have support for other protocols. So there is a lot of interoperability which can be enabled via these supportive protocols, right? So that's a quick intro to our platform. Just to give you, again, for the benefit of folks who are not familiar with StreamNative, the way you can access our product, we make it available through three different types of offerings which come as deployment choices. So we have the hosted and the bring your own cloud offerings, which is fully managed by StreamNative. Hosted runs in the user's customers cloud account. Hosted runs in StreamNative's cloud account, and bring your own cloud is something which runs in customer's account, a cloud account, right? But like both are fully managed by StreamNative. Private cloud is a capability which can be deployed in either any customer's data center or their choice of cloud provider, as long as they can self-manage it, right? So we have a Kubernetes ability to deploy private cloud on the Kubernetes platform through Helm charts and other capabilities, right? And you can self-manage. So the customers get all the capabilities and the features, the premium capabilities in private cloud also, but the only thing is they have to self-manage this by themselves. Okay, so those are the deployments. Now we'll also bring up just a few use cases quickly, right? So in the StreamNative is in the event data streaming space. We help customers quickly move data and move it to a destination of their choice in a data format of their choice and all those things. But I think some of the core use cases associated with data streaming are basically wherever there's a need for access to data in real time or near real time. Which means that the access to data with low latency or little closer to lower latency, latency sensitive applications. So these are like industries like fintech, where they want to ensure they are keeping a track on fraud which is happening, and they want to know when some sort of such event is happening, so they can notify the user, the customer, and also they can take action, right? So there are lots of such use cases. I won't cover a lot of them, but essentially it's setting the context for a lot of users here today on this session that for StreamNative, a lot of the core data streaming use cases, even data streaming use cases, are applicable, and we help customers accomplish that through our offerings, right? All right. So a little more on the data streaming space. Again, from my perspective, there are four blocks which form the whole data streaming space. The first part is the connectivity, where any enterprise needs a quick way to connect to your systems, like source applications or the destination where you're sending the data, right? So if you don't have a quick way to do that, then I think they spend a lot of time just building that out, right? So that's the number one problem, and I think we try to solve that through our connectivity portfolio. I won't be covering that today, but I think we do have a lot of solutions through our connectors and other capabilities to help you connect to your systems very quickly. And then processing. This is what I'll cover a lot today. I think I'm going to talk about what we offer as a built-in capability to process your data as that comes into StreamNative Cloud, and then transform that to a form and store it in a form which then can be easily consumed by other services. So governance is super important. This is also a capability which we offer through some of our support for schema registry and other areas. it is really important for customers to know that the data which is coming in is well vetted and can be trusted by the teams who are consuming it. And of course, delivering the data through streams, having the ability to store them as topics, that's something which we offer. So these are some 4 blocks. Today, what I'll be covering is the process piece, and then going a little deeper into it. Okay, so just a few more use cases now. The use cases which I covered before were like related to generic set of use cases for event streaming, but I think there are some use cases which are very specific to data processing. So there are different scenarios where as the data comes into, like as the customers want to move data through their pipelines, they also want to do lightweight transformations for them, right? So I won't cover each use case here, but let's pick one of them, like user enrichment of data, right? And so there are situations where as the order information or customer information is coming in, like you want to probably just add more information about that order or the customer by invoking yet another service and combining that and then storing that as a new record. So it's ready to be consumed by a downstream system, right? So that's a very simple use case, but I think there are a lot more other complex scenarios where people want to like track a set of data coming in a span of time and then be able to kind of grab that and process that, store that separately, and then push it down for further downstream processing, right? So there are lots of use cases for data processing. I'm just setting the context for data processing here. So what we offer for data processing within StreamNative Cloud is a fully managed service. It's called StreamNative Functions. Functions are a part of our core Apache Pulsar technology. But what we do is we take that and make it fully manageable by us. We manage it for the customer, so customers can rely more on deploying their logic, their transformation logic, and whatever type of applications, the data stream processing applications, which they want to deploy rather than worrying about the infrastructure for functions, right? So it offers, I wouldn't by any means say that this is sort of a complete alternative to Flink or some of the other heavy duty processing like frameworks which are out there for processing data. No, I think I would say those are very much, they have their own bigger use cases for leveraging that. But for functions, definitely is a quick, lightweight mechanism for you to make changes to your data as that is flowing through our cloud, right? And again, sometimes I see that Flink and other capabilities, while they're so powerful, they can also be very overwhelming in terms of the skill sets you need to kind of be able to set that up and use it. If your need is very small and lightweight for doing these transformations, then functions are a very good solution for that, and particularly since they are fully managed by us, right? So just a little more on functions. Basically, we offer like end-to-end tools for you to kind of build, deploy, debug, and monitor your data stream processing applications with functions, which are deployed on functions. So we offer, I would say, about 5 languages, language runtimes and SDKs in which you can deploy your functions. There is Java, Python, Golang, Node.js, and Wasm. There are like 5 of them. And essentially, and for deployment, of course, we offer our command line tools, the APIs, and Terraform. We have some capability in the UI. I'll show you that, but there's more we are working on. For debugging, of course, we give you full access to the logs, which you can access from the UI or from command line and API as well. Or we have this concept of logs topic. So whenever the logs are happening in the functions downtime, you can just push that to a specific logs topic. And if you want to even push that to Elastic or Datadog or somewhere else, you can do that too through a connector. But you have full access to logs, right? And then for monitoring, of course, this is really important because at the end of the day, when you deploy applications, you want to be able to monitor them. We offer a range of metrics which are exportable, and can be integrated with some of these popular observability services, Datadog, Prometheus, New Relic, Grafana, and OpenTelemetry. We integrate well with them. So we have these end-to-end tools so that customers can focus more on relying on a fully managed service and leverage this, right? So that's a little bit about functions. Functions are a part of StreamNative Cloud, fully managed service for processing your data stream applications, right? data processing application. So what I want to do now is I'm also keeping an eye on the time. I want to cover a few patterns. So to give you an idea, like about the type of use cases which some of our customers are implementing and what is popular out there. There are much more complex use cases as well, but I'm kind of keeping the focus to some of the more obvious ones, right? So I have like about 5 or 6 patterns here, but I'm going to cover just 2 or 3 so you get a sense of it. For example, the first one is a content filtering pattern, right? So this is where we have different sources on the left, we have destination on the right, StreamNative Cloud right here. As the data comes into StreamNative Cloud, basically, let's pick this example where there are situations where customers want to look up the record as and when it comes, and they want to be able to see, inspect it for certain keywords, right? I'm just making an example of a personalized news feed here, and either filter off the words which you don't need, or actually only grab the content based on the words you're looking for. Whatever is your transformation logic or basically filtering logic, you can deploy that as a Java function. And again, it can be in Java or it can be in Python, any of the languages. You deploy that. Once that's deployed, basically it's very declarative. So you can specify what's your input topic, what's your output topic. So every time a new record comes into your topic, automatically that triggers a function, and and it passes that record and context to the function. So it's going to start executing that, and it's going to filter that data, and then it has a way to pass it to the output topic. So it'll automatically just go and write the new record there, right? So that's one example of the way it works. Again, just to summarize, as a user, you would deploy a function once and specify input and output topic. And then every time a new record comes in topic, it triggers your function, and function will process the data and push that to the output topic, right? So a lot of that is declarative. The only part which is custom is your logic, your code, right? And we fully manage this function piece for you as it runs, and we'll let you scale that and all that stuff, right? So that's first. Message filtering pattern is very similar. In this case, you're not looking for keywords, you're looking for probably certain specific attributes. If it's an IoT sensor data, are you looking for temperatures? Are they crossing a certain limit? And what should you actually do, or whatever you want to do when that happens, right? So you can deploy your logic there, right? This is yeah, a different type of pattern, enrichment pattern. I briefly spoke about that before. I'll also cover this in my demo a little bit. This is a scenario where, let's say, a order data is coming, and if you want to basically fetch more information about the customer who placed that order, or if you want to get more details about the product itself, you can invoke an external service, grab that data, and combine that into, like, let's say, a new record, and then store that as output topic, right? So in this case, you are enriching the data with more information than what you received. And now this is a more kind of consumable and ready for the service as that data goes down to your destination, right? So that's the third pattern. Yeah, so there are lots of patterns. I'll just cover one more. Routing pattern is just how you want to, this is a popular one too, where based on your logic, you can, particularly in financial services, right? Like depending on the transaction which is coming in, you can move your data separately, whether it's withdrawal, deposit, or transfer or payment. You can store that as separate topics, and that goes nicely, cleanly to the destination, right? This is one of those examples. Transformation is another one. Of course, you can convert your data to any of the other formats, whether changing of schemas or any other format changes, any transformation logic at all, right? So yeah, this is another one, gathering pattern, just like the opposite of the previous one, where you're collecting data from different sources and then pushing this to one topic, right? So those were the patterns of some of the patterns which people implement in StreamNative Cloud using StreamNative functions to process the data. The beauty about that is there is basically data sitting. We are bringing the compute next to the data. Data is coming in, and we're saying, hey, your data is already in the topics. Let me give you some compute capability. So you can grab that data, which is in the context right there, and no extra infrastructure needed for anything. You just run the function and it's going to do your transformation. And so I feel that's pretty powerful. And I think we are working hard to improve that whole experience there. Anyway, so coming to the next thing which I want to talk about a little bit, which is stateless versus stateful functions. Again, there are in stateless functions, typically there is a scenario where you don't really care about as you're processing the data, as you're executing any of those patterns, which I covered before, you will essentially, you don't have to worry about storing any kind of information for your reference, right? And then, but there are other scenarios where you have to, like in this case, if you want to calculate an average of all the events which are coming in, you want to be able to know about all the events which are in a time span of like in a certain duration, and then be able to calculate it accurately. So for that, there are times when you have to store the state, right? Because it's referenced between, you know, either one function or multiple functions. So I think that's an important capability. I'm just sharing something. We do have a sort of alpha release. We have a very basic capability for supporting stateful functions today, but I would say it's in a very early stage. The reason I'm sharing that here is because we do have plans of like supporting stateful functions in the future. And that's what we are working towards. It's still an early stage. If there's anybody on the call who is interested in stateful functions, knowing more about it, I'm happy to, please do reach out to me. And I can, you know, perhaps explore your use cases and we can work together to see how we can get you this preview, right? But I think we're still working on that. This is a good segue into what we plan to cover in the future, right? I think we definitely plan to support stateful functions. We'll have a public preview for that. And we're going to leverage Oxia, which is a metadata infrastructure platform, which is going to give us that scale because Oxia runs on Kubernetes. And that's something which we want to leverage for this capability. So we are sort of working towards that. So we'll keep you posted when that happens. We have a few other changes also coming in. We want to improve our UI for the experience around deployment of functions. Also, like, you know, focus on the auto scaling use cases and things like that, right? So that's a quick sneak peek. I'm actually ready to move into the demo. Just again, for the benefit of folks who have never tried it or never seen StreamNative functions, I thought I'll quickly show something. But before that, I want to before I go to the demo, I want to just give you the demo scenario a little bit here. So again, this is StreamNative Cloud. What I'm going to show is basically, you know, imagine there is a data which is streamed into the cloud. And for that, I'm going to run a producer application. What I'm going to cover here is essentially the enrichment pattern, which I spoke about before. Whereas the data comes in, like, you know, let's say in this case, this is the user data, which is coming in. And I have some basic information about this user ID, name, and other things, all the way till profession. I want to actually enrich this with more information so that it's ready to be consumed by the other service. Like I'm going to pull up social media profiles, LinkedIn, Twitter, other interests of this user, and some sort of purchases which these users done. So now we have a richer information about this user, who is looking at this user, right? So imagine this is done by invoking an external service, and then, you know, pulling that data together, and that function is going to combine that data and push it into the targeted topic. So in this case, I'm highlighting this is the original record which came in, and this is what you will see is the additional enrichment which is added to the record. So ultimately, the user profile is more richer now, and it's ready to kind of get pushed. Now, I'm not going to, for the sake of completeness, I've shown this flow where ideally you could use a connector or something else to move your data to your destination. But I won't be going into that today, just in the interest of time, right? Okay, so I have a quick demo. I'm going to quickly go into that, and then I'm going to hand over to Matt. So I'm looking at actually the timeline. Let me see. Okay, so let me go into, give me 1 second. Okay, so I'm going to go into my into the StreamNative Cloud, and this is again for the folks who are not familiar with StreamNative Cloud. This is the fully managed service for both Pulsar and Kafka. I'm going to jump to some of the specific terminologies right now, just in the interest of time. There are lots of capabilities, but I'm going to go to functions. Right now, I don't have any functions deployed. What I'm going to do is, again, deploy a function, which is going to, okay, give me one moment. I already have a function here. So perhaps I can go ahead and sort of delete this. Okay. So I want to, while I sort of create my function, I want to quickly show you the command for that. Yeah. So this is my Pulsar curl command. I'm deploying a function, entry chooser info, and just giving the input and output topic. And then essentially specifying also the log topic where some logs can go. This is my jar, and that's it. So that's the information, right? And also, I think I'll quickly show, let me see if I can bring this up here. Yeah, so this is my code basically, which is just enriching the profile. So essentially, as you let me expand this. Yeah, so it's basically you write a Java class which implements a certain, like it basically implements a function. It has got its own set of methods which we'll have to implement because it's an interface. And then it'll pass the input. This is the input record which is coming in. And this is the context which gives you more information about the runtime. So all I'm doing is basically, again, I'm not invoking an external service here. I'm just hard coding some of the stuff just to keep it simple. But you enrich the profile, you create a new record, right? And then you basically just return that record to runtime, and that goes to the output topic, right? So that's what we have there. And then I'm also going to do, so that was the function, and I'm going to deploy this real quick. So the function is now deployed, and you saw it showed up right behind very quickly. And okay, it's showing me there's an error. Give me 1 second. No, it's up and running. All right, so I think I'm going to go into this function just to show you what it looks like in runtime. So once you get into the function, you'll see more information here, the overview, and it has information about what is the input topic. Basic user info is my input topic, and this is the topic where I'll put the enriched information. Yeah, and things like that. So let me come back here. So the key thing is now this function is going to execute and put some data into, it is going to go look for this topic, which is the basic user info. I'm going to quickly show you some payloads here. So let's see. I'm in my topic UI, which is now quickly I'm looking at the out-of-the-box feature here, which lets me view into the data of that topic. So this is the record I was talking about. This is the input record, all the way till profession, right? User ID, all that stuff, profession. We want to enrich this, and you want to add more stuff to it, right? And so the function is automatically running, and what I'm gonna do is very quickly, I'm gonna populate some more data here. So I go to my producer application, which is just going to run and populate like a few records. You see all these records are now populated into the topic. So I'm going to go back to my topic. So here the data is added. So essentially, once the function is automatically running as the record comes in, it starts enriching that, and then it stores data into this output topic, right? So let me quickly bring that up. Okay. So now you see, let me go slowly here. So we have user ID, profession. So all this extra stuff which you see here, that's actually added by the function. So in a scenario, in realistic scenario, it would just pull up, like invoke a third-party service based on the customer ID or the, user ID. And it's going to get all this information from yet another service and combine that. And then you have this new payload stored into the output topic, right? So it's a very simple example. So so that's a little bit on that. I know I'm running short on time, so I'm going to wrap this demo here. Again, going back to what we saw is essentially the data came into the topic, and then we triggered a function for every record which came in, and we executed some custom logic to enrich that data and store that into the output topic, right? And then from there on, you can push that to the downstream processing, right? So that's a fully managed service, functions, StreamNative functions, and StreamNative Cloud, right? So that's about it. Now I'm going to hand it over to Matt, which is the real part of the session today. So I think, give me 1 second, Matt, over to you.
Awesome. Thank you for that. Let's just share my screen. Okay. You can see my screen okay? Yep.
Yes.
Perfect. Okay. Innerspace has been a long time StreamNative customer, and I wanted to give everybody the insight into how StreamNative has made our business better, and it's allowed us to not focus on infrastructure, but focus on product. So why don't I kind of start from the beginning here? So what is Innerspace for people who don't know? Um, Businesses invest in real estate, a lot of money in real estate, but they don't really measure the performance of the real estate. They don't measure the impact of real estate on the people that use it, right? But Innerspace can. Innerspace can give you a measure of performance and show you how it impacts the productivity of your workspace or your workforce or the people using your buildings, right? And we do that using existing Wi-Fi. You don't need any additional sensors. Use your existing Wi-Fi. So why Wi-Fi? Because it's there and people have Wi-Fi devices and Wi-Fi devices can be tracked. Some people have multiple Wi-Fi devices and we have ways of turning multiple Wi-Fi devices into a single person. And why not use sensors? Well, sensors are hard to install first. They're expensive to install and they need to be maintained and kept online, right? So there's effort there. But Wi-Fi is already there. Every building or office or educational campus has Wi-Fi. It's already available. It's already maintained. It's business critical. If it goes down, so does the productivity of everybody on campus or everybody in the building. So IT keeps this up. So why not leverage it? Let's use it. And we do. Okay. So before questions pop up, we do anonymize Wi-Fi devices to ensure privacy is maintained. It's super important to us. We aggregate data. We never isolate individuals. And we follow GDPR very closely. Okay. So Wi-Fi allows us to do really cool stuff, more than sensors do. Wi-Fi allows us to see where people go over time. You can see common pathways. You can see how people go from their workspaces to, food or to meeting rooms or anywhere. You can also identify groups of people by behavior. Maybe a group of people who arrive early to work or a group of people who leave late. You can also identify groups of people by location. Maybe it's the marketing team in the office or it's the engineering students on campus, right? You can start slicing and dicing your data by types of people or people who exhibit certain types of behaviors. You can then see how these groups of people use the buildings or the floors or the rooms or the spaces. You really start to understand how people use the space and how it impacts their productivity or how well they use the space or how excited they are. So another common question that comes up is Wi-Fi accurate enough? It is if you take a different approach. So we created a new algorithm called predictive hyperbolic location fingerprinting that will calculate locations within 1.3 meters 90% of the time. It works with your existing Wi-Fi infrastructure. You don't need to upgrade, just use your existing Wi-Fi infrastructure. No additional sensors, no additional hardware. But I mean, if you have a not very dense Wi-Fi infrastructure and you want to increase accuracy, you just need to tell Innerspace where stationary Wi-Fi hardware is in your space, like printers or screens, anything that's using Wi-Fi or desktops that are just sitting there. Instantly, and once you add those devices to the Innerspace configuration, accuracy improves around that device. So there's an easy way to improve accuracy if needed. Okay, so what does data flow look like? What data does Innerspace get to to give us this magic information? Well, we ingest RSSI data. Right? What does that mean? Well, that's the Wi-Fi access point's MAC address, the client's MAC address, meaning the person's laptop or phone, the timestamp, the band, the signal strength. Okay, so the first question you'll have is privacy. We turn the client MAC addresses we anonymize them, one-way hash them upon receipt so that we don't know who that person is. We just know that there's a person there, right? Okay. So then we turn that information into client locations every 60 seconds. So how much data is this? What's the volume of data flow here? It's high. And processing latency is critical for us, right? We receive data, batches of data right now every 60 seconds. We can also do it in real time, but 60 seconds is a sweet spot. And typically we see tens of thousands of packets or messages per minute. And we have functions processing each floor and converting them to locations every 60 seconds. Execution time and memory requirements change all the time, right? They increase with volume. So we monitor this stuff closely. And Prometheus and Grafana are close to my heart. So we monitor all this stuff all the time. And it helps us alert and adjust resources as necessary. So how does this work? At a high level, Wi-Fi access points push data to Innerspace using existing vendor-provided hooks. Wi-Fi vendors such as Arista, Aruba, Cisco, Juniper, Ruckus, and more provide these hooks out of the box. So there's no customizations needed. You're using existing hooks. This data is then pushed to Innerspace Cloud, where it's converted to client locations, then insights, and made available through our portal and our API. Okay, so we started before using StreamNative, and we had bottlenecks for growth. So what kinds of bottlenecks or problems did we see initially? So processing speed and latency was super important to us. We're processing data every 60 seconds. Volume of messages and processing and topics and functions was super important to us too. Scaling horizontally, obviously critical. We bring on big customers all the time, and we need to be able to scale horizontally. Cost is obviously important. It varies by time. During the day, it's super busy in an office building. At night, it's not. And it needs to be simple. We wanted something that was simple and manageable by less than one person. We don't want a DevOps team managing, you know, a 10-person DevOps team managing our infrastructure. We'd love for it to be one person or less than one person. So where did we start? We started with, like everybody, rolling our own, right? We started by using OpenFaaS, which was a function as a service provider in our own environment. And we had data flowing in to queues. So we had a raw data queue that turned into a location queue and then pushed to our data science team, right? Raw data queues were really big, and we had functions running through OpenFaaS that would convert them to locations. And then we would have functions converting them from locations to usable information that the data science team needed. And what worked here? Well, it was really fast. Function as a service was great. We executed quickly. Latency was short, but volume was a problem. We could only do small deployments. Everything was patched together. We built it all ourselves. And it was manually provisioned. It was hard. Cost was high. It was always on. And it wasn't simple. We had multiple stacks. We had OpenFaaS. We had a bunch of different queue providers. So we were constantly managing this stuff. So this is where we started, and we know we had to move somewhere else. So what did we try? We tried things like Event Hub, right? But it couldn't keep up with the processing demands. The speed wasn't there. The latency wasn't there. It could only handle small deployments. The scale was mostly, we could automate CI/CD to get everything out. The cost was high. And it was simple because it was a single stack all brought together, but it didn't hit speed, and that was a problem. So after lots of digging and digging and digging, we found Pulsar, and we actually found StreamNative as a Pulsar provider. Um, and we did a quick investigation, and we found speed was great, function execution time was great, latency was low, um, because they were always warm, and it satisfied our speed requirement. It also satisfied our volume requirement because it can scale. You can add more bookies, you can add more topics, you can add more resources. It's all run off Kubernetes, so it handled large deployments, and we could script everything. So we use CI/CD to deploy functions as needed. We use CI/CD to create new topics. So everything was scriptable and and automated. Cost was great, because it combined both our processing time and management, which is amazing. Um, in this case, we were actually, just to clarify, we started with bring your own cloud. So we had StreamNative managing Pulsar in our own cloud. So was it simple? It was sort of simple. We had to manage some of the infrastructure while StreamNative managed the rest. And where are we going, or where are we right now? Well, we're almost fully in cloud Pulsar right now, because we recognize that, you know, consolidating makes a lot of sense. Let's have the full stack managed so that everything is managed together in one place. So we're almost there right now. This also helps us with costing because we don't have an infrastructure bill and a management bill. Everything's together. So the cost ends up being lower than them separately. So it's solved a lot of problems for us, and it's great. So this is kind of where we landed. StreamNative gave us functions that execute quickly with low latency. We're able to CI/CD deploy them very simply. They solved our volume problem because we can have almost unbounded number of topics and functions, which is great. It scales horizontally with different deployments. Again, CI/CD can manage everything here. And the cost was actually half the cost of our managed Pulsar deployment, which is amazing. It's working out really well for us. And it's super simple. Everything's managed externally. We have very little DevOps involvement here, which is great. So the solution, all things considered, is awesome. And what's next for us right now? So we're in once we get fully in StreamNative Cloud, our next big goal is to hit vertical function scaling. And what does vertical function scaling mean? We actually submitted this as a ticket a number of years ago, saying, "Hey, we have this problem. If you can imagine an office building, it's very busy during the day, right? Or you can imagine a football stadium. It's very busy for 4 or 5, 6 hours, and then it's empty. So we wanted the ability to scale function resources dynamically. And that means ramp up resources during the day or when it's busy, and then ramp it down at night, right? Which helps us manage costs. And StreamNative implemented it for us, which is awesome. And we're just shifting over to using it. So it handles our spikes in activity, and it reduces our costs when costs are low. So as a quick 2-minute intro into like okay, so this is Innerspace. How do people deploy this? It's actually pretty simple. So as an example for Cisco Meraki, if you want to integrate Innerspace or start sending that Wi-Fi RSSI data to Innerspace, you fill in these 3 blanks in the Meraki configuration portal. And it's the same across every Wi-Fi vendor. It's very similar. It's about 15 minutes worth of time for an IT person to enable this. And then on the other side, we also need floor plans and the ability to mark up areas that you're interested in getting insights for. And these areas can be rooms, they can be floors, they can be an amalgamation of rooms, it could be anything you want. We need a floor plan and to draw those zones or areas of interest on top. And then we need to know the WAP locations. Where are all the Wi-Fi access points? Once we get that, this usually takes a little bit of time back and forth with our solutions engineers. And then once we get that, then we start delivering insights to your customers, to you, right? How many people are using your space? Where are they going? Who are the early birds? How many early birds are there? How many people use the office late at night? All this information starts flowing and becoming available to you. And that's it. It's pretty simple. I have two really quick data security and compliance. We're ISO certified, SOC 2, GDPR. Privacy is super important to us. But I won't go into the details on that. Just know that it's there. And that's Innerspace. Happy to answer any questions anybody has about it, but I'll hand control back.
Awesome. Thank you so much, Matt. That was so insightful. I think really great to hear your journey. Let me share my screen again. Give me 1 second. Okay. So yeah, I think you heard about from Matt. I think something for you to kind of go back and think about your use cases. Like, they've seen success with StreamNative functions and BYOC. So if anybody has questions, please do reach out to us. Happy to get you started. The best way to get started is just sign up for a trial. You can just go to our streamnative.io website and you'll find a link there, or you can just scan this barcode right now and that'll take you there as well. Okay. You can also book a demo if you want to just get a more one-on-one session with us. We also have a lovely book on Apache Pulsar, which covers a lot of things, including functions, a lot of in-depth content there for functions and other areas by David. This is a complimentary copy. If you can scan this, it'll basically take you to a link where you can access the book. So please give that a shot. It's a lovely book. You can download and go through it. And also, I just want to highlight before I go to the Q&A that we have a summit coming up. This is the Data Streaming Summit, which is planned for October 20th and 29th. This used to be called Pulsar Summit before, but now we've renamed it as Data Streaming Summit because I think as I mentioned right in the beginning, we are now not just a Pulsar company, we're also a Kafka company. So we are fully committed to support all the streaming use cases and help customers, implement them. So you can come to the session for the folk. This is happening in San Francisco Bay Area. If there are any interesting talks you want to submit and be a part of it, please do so. We have links on that. So you can find this information on our Data Streaming Summit site. Cool. Sounds good. So I think maybe we can just switch to Q&A. We have a few more minutes left. Let me see what else is. I'm going to stop sharing. Just 1 second. Just want to see what type of questions are coming up. Okay. Okay, I think there's a question. Probably this one is for you, Matt. I think let me see. You said that you did not need a big DevOps team. Were you able to redirect your resources elsewhere, like build more value-added services for your customers? Anything you want to share there?
Yeah, that was that's a great question because that was one of our goals. We wanted to not focus on infrastructure. We want to focus on actually delivering value to our customers. And that's what StreamNative gave us, right? It gave us the simplicity of having just, a fractional DevOps person help manage this stuff, which allowed us to focus more on customer development and product development, which is great. And that's always the goal for most of our stuff. And StreamNative worked with us to get there. Just for context, we've been a StreamNative customer for I want to say 6 or 7 years. We've been here for a long time, and we've grown with them, and they're fantastic. I can't say better things about them.
Awesome. Thanks a lot, Matt. Uh, and I think, let me see if there's anything else. There's one more. Is the function scalability available? Like, I think it was in the StreamNative, yeah, the private cloud. So yeah, I think the question is the functions capability available in StreamNative private cloud? Yes, very much that is. So I think all the private cloud features are also our premium set of capabilities. Whatever improvements we do in our core product, it goes to both pretty much most of the times managed cloud and private cloud. So yes, you can very much access StreamNative functions in private cloud as well. Let me see if there's any other questions here. Yeah, I think there's a question about the connectors. What type of connectors are these? I think the ones which I mentioned in the beginning, these are, so the 50 plus connectors I referred to are mostly the Pulsar IO connectors. That's what we support today. You'll also hear about other announcements coming soon in our cloud, perhaps next month or so. There's some big announcement we're planning around connectors. But yeah, as the one which I show right now, it's more based on the Pulsar IO framework. I also referenced the term connector for the integration with Flink and Spark. So those are separate connectors which are designed to run on either Flink runtime or Spark runtime, and it talks to Pulsar and pulls data from there. So those are separate connectors. But yeah, these were the ones which I showed there was the Pulsar IO connectors, the 50 plus connectors. Cool, let me see. So that's about it. I don't think there are any other questions right now. Yeah, I'll just see if there's anything else. Okay. So I think we're just about time. I don't see any other questions, but I would say thank you so much, Matt. I think this has been extremely valuable for our, for the folks who have attended, and I think for me particularly to hear your journey. So thank you so much for taking the time to be a part of the session today.
Yeah, thanks for having me here. I appreciate it.
No, thank you. All right. Have a nice day, rest of you.